Hello everyone, Assalamu alaikum. So welcome to my class of computer networks. So we are going to talk about the subnetting techniques today. So let's see the contents of today's class. Let's have an overview. So we are going to cover subnetting today. So subnetting, why it is needed, what is subnetting, type of subnetting techniques, and lastly we are going to solve a problem related to subnetting. So what is subnetting? Subnetting means creating subnetworks. Let's say we may have a given network address and we want to create the subnetworks. To create the subnetworks, we need to divide the given network address. So to divide this network address, we have some techniques to divide it, and this process is called subnetting. So let's have an example here. We have a IP address of class C, that is 192.168.0.0/26. So the first portion of the slash is the network and the 26 is called subnet mask. So we can see this is the given network address and we are going to solve this later. So let's go to the next. So we have some techniques I have already said, and they are Flsm and Vlsm. Flsm means fixed length subnet mask and Vlsm means variable length subnet mask. So there is some difference between Flsm and Vlsm. We are not going to talk about this today. We are going to solve the only portion Flsm today. So first of all we have to know what is Flsm. So Flsm means fixed length subnet mask. This is called the class full subnetting when we are given a class address like this IP address range is class C. So if we need to divide this address, we can use Flsm or Vlsm, anything, but why Flsm and why Vlsm, it may differ from situation to situation. But today we are going to talk about Flsm, as I said before. So I have already said that it is known as classful subnetting. Divide the subnet into subnetworks. This subnet is also said a network. So the final outcome will be the subnetwork, which will come from a given network and where the length is fixed. That's why this technique is called Flsm, that means fixed length, where the length is fixed. So first of all we are going to cover up the classes, usable classes for our host. So here we can see that in class A we know that IP address have two versions. One is IPv4 and one is IPv6. In IPv4 we use dotted decimal to represent the IP addresses. So we have 4 octets here. In class A we have network host host host. That means first octet is the network and the rest of the octet are host. Similarly, class B has 2 octet as network and 2 octet as host, and class C also has the similarities. 3 octets are network and only 1 is host. So let's see the subnet mask, the default subnet mask of each classes. So class A has /8, that means the network bit will be 255. That means this network bit will be only 255. In class B we have the default mask 16, that means the network bits will be 255. That means we have 255 twice here. In class C we have /24, so first 24 bits will be network, that means network. These 3 octets will be 255 and only one will be 0, that is host. I have written here. So let's solve a problem related to subnetting and Flsm. So let's say we have network address 192.168.0.0/26. So we have to find out how many subnets does the above subnet mask has. That means we have to find out the subnets using this /26. The second question is how many valid hosts per subnets. Third is what are the valid network addresses. So that means we are dividing the network, given network, into subnetworks. We have to find out the valid networks, the valid subnetwork addresses. Fourth is what is the broadcast address. We will talk later on it. Fifth is what are the first IP addresses of all subnets. And the sixth number is what are the last IP address of all subnets. So let's go to the solution. So let's see that we have the given address is 192.168.0.0/26. so that this 26 can be written as 225.225.225. as we know this IP address belongs to class C, so we can write first 3 octet as 255, as we can say that the class is C. But we have /26, that means we have 2 more bits to be the network bits. That means how we can write 26 in binary format. So this 255 can be written as 1, total number of 1 will be 8, that means the binary bit will be 8 in each octet. So 255, for this we can write 8 1 here. For this 255 we can write 1 8 here, 1 1 1 1 1 1 1 1. So we have 8 ones here. Similarly for this 255 we can write again 8 ones here. So our third octet has ended here, but we have /26, that means first 24 is ended here, but for more 2 bits we are borrowing from the last octet, that means this position and this position. So we have total 26 ones in total here from the total number of bits. We have total number of bits 32, and as we have /26 we have written 26 1 here, and the rest of the bits will be host bits. So here we have 6 host bits for the subnetting. So let's go through this. Okay, I have already said that the given network address belongs to class C, and for this the default subnet mask will be /24. This /24 can be written as 255.255.255.0, and again we can write it as a binary format. This 8 means 255, this 81 means 255, this 81 means 255/0. So this is our default subnet mask. So let's talk about how we can find subnet or network. To find it, we have some rules to solve this. So how to solve this kind of problems? Let's go through this. Here x means subnet mask, mask bit. So what is mask bit? The mask bit will be the given bit minus the default bit. The given bit is 26, as we have seen in our problem that we have given /26. Again, as we are using class C IP address, the default subnet mask will be 24. So if we subtract these two, we will get 2. So the rule is 2 to the power x. That means we are getting x equals to 2. That means 2 to the power 2 equals to 4. So the total subnets will be 4. So the next question was, what are the valid hosts? Okay, so to find this, we have also have another rule, that is y equals to, how we can find it? We have total bit 32 and we have given bit 26. That means that our given is the given bit and total number of bit is 32, as we have 4 octets and each octet has 8 bits per. So 4 into 8, that means 32, and the given bit is 26. So if we subtract these two, we get only 6. So the formula is 2 to the power y. That means 2 to the power 2 to the power y. That means we get y equals to 6. 2 to the power 6 minus 2 equals to 62. Why minus 2? The minus 2 is for the one IP address is network address and another one is broadcast address. That 2 we can never use for host. So we subtract these 2. So as we are finding valid host, so we have to subtract these 2 because we can never use them as an host. So we are subtracting network address and broadcast address. That means the valid host is 62. So let's find out the block size. So we have block size. So how we can find the block size? For class C, in the last octet is our host. So if we calculate, it starts from 0 and ends at 255. If we count from 0 to 255, we get 256. Total 256 is there, and as we have given /26, that means these 2 bits are counted. That means the first bit is 128 and the second is 64. If we sum up of these 2, we get 192. So here we just subtract them from the total minus the borrow. That means in the last octet we are taking 2 ones, and if we sum up them, then we get 192. So if we subtract them, we get 64 as our block size. So if we organize them in the manner, we can find the valid subnets. So first will be 0 to 63. As it is 64, we know that we start counting from 0. So if we start counting from 0 to 63 will be the range. That means 0 to 63 will be total 64. So the first subnet will be starting from 192.168.0.0 to 63. This is the first subnet, and second will be started from the next of the broadcast address. This IP address is called the broadcast address. How we can find the broadcast address? The first IP will be the network address and the last IP will be the broadcast address, and the next subnet will be the broadcast address of the first IP plus 1. That means 63 plus 1 equal to 64. So the 64 will be the next subnet address. That means network address. So the next subnets will be starting from 192.168.0.64. As we know, our block size is 64. So if we sum up this 64 with this 64, we got 128. Again, if we sum up with 128 plus 64, we get 192, and the range will be from 190, like here 64 plus 63, as we got the block size 64 and we are starting from 0 to 63. That means the range will be 64, but we are adding 63 here to get the range, as this 64 is also in the range of this. So this way we are getting the valid subnets. So the last question was the subnet. Here we have written in the table to understand it better. So if it is the subnet 1 and this is the network address NA and this is the broadcast address BA, so what will be the first IP address? The first IP address will be the next of the network address. That means 192.168.0.1. This is the first IP address. Similarly, the broadcast address, the last IP will be the previous of the broadcast address. So here we have got 192.168.0.63. so the previous IP is 192.168.0.62. Similarly, we can calculate for the subnet 2, subnet 3 and subnet 4 accordingly. So that's it for the FLSM. So if you have any questions, please write it down in the comment box. I will answer all the questions there. So thank you for attending my class.